Hello everyone. Today's topic of discussion is origin and evolution of the Earth. It is a part of 12th standard geography from the book Fundamentals of Physical Geography. Right? Let's start. We will go NCERT by line. If you remember that there used to be a nursery rhyme, Twinkle Twinkle Little Star, right? So in Starry Nights, you have always attracted us since the childhood. We have also heard thought of these stars have numerous questions in our mind. When we see them, there have been numerous questions in our mind. Questions that how many stars are there? Number of stars. How many stars are there? Others is how do they come into existence? So let's think and try to give them answers. So there is a first heading, early theories. Early theories on what? Origin of the earth. How did the earth origin? How did the earth origin? So there are different hypotheses, right? The different hypotheses which were given by scientists. So German philosopher named Immanuel Kant, Immanuel Kant. He was the first one to give the argument regarding the origin of the earth. Later, mathematician named Laplace. Who? Laplace. He also gave a theory which is also known as nebular hypothesis. Nebular hypothesis, right? It considered that planets were formed out of cloud of material associated with a youthful sun, which was slowly rotating. So that's regarding nebular hypothesis. Next, it was in 1950, Otto Schmidt in Russia and Carl Weizsäcker in Germany revised the nebular hypothesis. This was again revised, right? They considered that the sun was surrounded by solar nebula. There is a sun surrounded by solar nebula. Solar nebula, right? Containing mostly the hydrogen and helium along with them. They may be termed as dust, which contain hydrogen and helium, which were considered as dust. Which was considered as dust. The friction and collision of particles led to formation of disc-shaped clouds, and the planets were formed through the process. So that's not required to that how the formation, but the only things to be remembered is Immanuel Kant who gave the first theory, then Laplace who gave nebular hypothesis, and then there was again a revised nebular hypothesis in which there is a sun at center and hydrogen and helium are surrounding it, right? Then there is the topic of modern theories. Modern theories. So the most popular modern theory, as we all know, is the Big Bang theory. The Big Bang theory. It is also called as expanding universe hypothesis. Expanding universe hypothesis. Right? It was given by Edwin Hubble. There is a famous telescope of NASA, Hubble telescope. It was named on the honor of the scientist Edwin Hubble. right? In 1920, it provided evidence that the universe is expanding. Our universe is expanding, right? As time passes, the galaxies are moving further and further apart, right? So that's the regarding Big Bang theory. There is also a concept called singularity. So if the universe is expanding, example a point here, and universe is expanding in this way, then if we go back in time in past, then there has to be a point where everything is merged, right? That point is called a singularity point. What is called singularity point, right? So it is believed that it was hypothesized that at the Big Bang, the tiny ball at the time of Big Bang, this tiny ball, the singularity is a tiny ball, exploded, right? 13.7 billion years ago before the present, within which our formation and the first atom began to form. Within 30,000 years, the Big Bang temperature dropped to 4,500 Kelvin, right? So if this is singularity, then temperature here would be very high. But then temperature fall within 30,000 years only to 4,500 Kelvin, right? And alternating to this theory was a Hoyle's concept of steady state. Hoyle's scientist named Hoyle's get the concept of steady state, right? It considered universe to be roughly of the same at the point of time. However, with greater evidence becoming available about the expanding universe, scientist community at present favors the argument of expanding universe. So today, the most acceptable theory is the Big Bang theory, right? The Big Bang theory. Then there is next concept that the universe has been formed. Then was a formation of stars, formation of stars, right? The distribution of matter and energy was not even in early universe. So it was not equally distribution of matter and energy. This initial density differences gave rise to differences gravitational force and it caused the matter to get drawn together. So what's they are saying that the distribution was not even, was uneven, which led to difference in gravitational forces, bringing down matter together. So the because of uh, difference in gravitational force, the matter came together, right? This formed the basis of the development of galaxies, which formed galaxies, right? Formed galaxies. They spread over vast distances, which are measured in thousands of light years. Thousands of light years. The diameter of individual galaxy range from 80,000 to 1,50,000 light years. A galaxy starts to form by accumulation of hydrogen gas in the form of very large cloud called nebula. Galaxy forms due to accumulation of hydrogen gas, right? Hydrogen gas to form a very large cloud, which forms a very large cloud, which is known as nebula, right? Nebula. They can ask the definition about nebula, right? Then what happened then? There was a formation of planets. There was formation of planets. The stars are localized lumps of gases within nebula. What are stars? They are localized lump of gases within nebula. We saw the definition of nebula, large cloud, right? which was formed due to accumulation of hydrogen gas is called nebula. The gravitational force within the lumps leads to the formation of core to the gas cloud, and a huge rotating disk of glass and dust develops around the gas. So what's happened? What happens? The gravitational force within the lump. So there are lump. Lump means coming together. These lumps, within these lumps, there is a gravitational force, right? Where there is a gravitational force, which leads to the formation of core to the gas cloud and a huge rotating disk of gases. There would be a disk of gases and dust that develops around the gas core, right? In the next stage, the gas cloud starts getting condensed. So what will happen in the next stage? There is accumulation, then this gas cloud will start getting condensed. It start getting condensed. And the matter around the core develops into small rounded objects. These small rounded objects, by the process of cohesion, developed into what is called planetemism. So only we need to understand is what is planetemism. Right? The next heading is evolution of Earth. How our Earth came into existence. Evolution of Earth. The Earth was initially barren, rocky, and hot object. And hot object with a thin atmosphere of hydrogen and helium. Right? This is far from the present day picture of the Earth. Hence, there would be events or processes which turn this barren, hot Earth into a beautiful planet, right? So, here we will learn about how the atmosphere of the Earth got thicker. The Earth is a layered structure from the outermost end of atmosphere to the center of the Earth. The material that exists is not uniform. The atmospheric matter has the least density. Atmospheric matter has the least density from the surface to deeper depth. The Earth's interior had deeper zones, and each of these contains material of different characteristics. So there are different zones, right? So which is the first zone? That is lithosphere. It is lithosphere. The Earth was mostly in a volatile state during its primordial age. Initially, Earth was very volatile. Due to gradual increase in the density of temperature inside it, there was a result of material inside Earth started getting separating depending on the densities. This allowed heavier metals like iron to sink downwards and at the center of the Earth and lighter to move towards the surface. With the passage of time, there was a cooling and solidification and this condensed into a small size. So basically in lithosphere, the denser material went downwards, the light denser material went upwards. This everything got condensed and moved towards the surface, right? And there was a solidification also. Next, evolution of atmosphere and hydrosphere. Atmosphere and hydrosphere, right? The present composition of Earth atmosphere is simply contributed by nitrogen and oxygen. What? Nitrogen and oxygen. There are three stages of evolution of the present atmosphere, right? The first stage is marked by the loss of primordial atmosphere. The initial atmosphere was lost. In second stage, the hot interior of the earth contributed to the evolution of the atmosphere. And finally, the composition of atmosphere were modified by the living world through the process of photosynthesis. In third stage, there was a process called photosynthesis. The early atmosphere with hydrogen and helium is supposed to have been stripped off as a result of solar winds. The solar winds stripped off hydrogen, and helium. This happened not only in case of Earth but also in all the terrestrial planets. In comment section, kindly mention what are terrestrial planets. Right? During the cooling of Earth, gases and the water vapor were released from interior solid Earth. This started the evolution of the present atmosphere. The early atmosphere contained mainly water vapor, nitrogen, CO2, methane, ammonia, and very little of oxygen. This process through which the gases were outpoured from the interior is called degassing. Degassing. Continuous volcanic eruptions contributed water vapor and gases to atmosphere. As a result, the earth cooled. The water vapor release started getting condensed. The carbon dioxide in atmosphere got dissolved in rainwater and the temperature further decreased, causing more condensation and more rains. The rainwater falling into the surface got collected into depression to give rise to ocean. The way which oceans were formed was because of this condensation, this cooling of this water gases, right? The Earth's oceans were found 500 million years from the formation of Earth. This tells us that oceans are as old as 4,000 million years, sometimes around 3,800 million years old, where life began to evolve. However, around 2,500 to 3,000 million years before the present, the process of photosynthesis got involved. Life was confined to the ocean for a long time. Initially, life was confined mainly to oceans. Oceans began to have contributed to oxygen through the process of photosynthesis. Eventually, oceans were saturated with oxygen. Oceans were saturated with oxygen 2000 million years ago, and oxygen began to flood to the atmosphere. Similarly, what happened that the oceans oxygen bearing capacity was at maximum, and thus oxygen came to atmosphere. The last phase of evolution of the earth relates to origin and evolution of life. Origin and evolution of life, right? It is undoubtedly clear that initially the earth or even the atmosphere of earth was not conducive for the development of life. Modern scientists refer to the origin of life as a kind of chemical reaction, which first generated complex organic molecules and assembled them. This assemblage was such that they could duplicate themselves, converting into inanimate matter into living substances. The record of list that existed on this planet in the different period is found in the rocks on the basis of fossils. The microscopic structure closely related to the present form blue algae have been found geological formation much older than some of the 3000 million years. It can be assumed that life began to evolve sometimes around 3800 million years ago. So basically that is regarding origin of universe, origin of earth, life on earth. So basically what we learned in this chapter, origin and evolution of earth, right? Different theories which was earlier given by Immanuel Kant and Laplace, which is called nebular hypothesis, which was further revised, right? In which hydrogen and helium were around. It's a structure called sun, which is called solar nebula. Then there are modern theories, and the widely acceptable is Big Bang theory, in which expandable, also known as expandable universe hypothesis. Here we understood the concept of singularity, and later in after 30,000 years, temperature was dropped to 4,500 kelvin. There is one more theory of worlds, that is steady state theory, which is not widely acceptable. Right? Then we learnt about stars formation, galaxy formation, accumulation, right? Formation of planets, evolution of Earth, then different stages on Earth, that is evolution of lithosphere, atmosphere, hydrosphere, terrestrial planets, right? That you have to give in comment section. Then there was a process called degassing, how the life began. Early life began in ocean, right? Early oxygen was consumed and by ocean, which was later released into atmosphere, and later we understood how the origin and evolution of life, and life is merely a chemical reaction. Isn't it interesting? So, thank you everyone.